So lesson 17D, can you feel the heat? Let's continue our exploration of long-term trends in climate data. We will see that variations from such trends are to be expected and do not contradict the overall pattern. We'll look at our data about our own planet Earth. Scientists are raising concerns about global warming, saying that the temperature of the Earth is increasing. If the Earth is getting warmer, then why is it still so cold in the winter? Does this mean that global warming is not happening? Then on question 1, what do you know about climate change or global warming? Go ahead and jot down some thoughts on this and then join me at the objectives. Some issues in our society are complex and involve multiple variables. So we're going to understand not only that, but that analyzing data is important in identifying trends about issues involving several variables. And then finding a pattern in data often means analyzing a large set of data or data values over time, not just an individual value. We'll also be able to analyze a regression line and use an R or an R-squared value to determine overall patterns and connections between variables. And finally, we'll be able to make decisions and conclusions based on data separately from anecdotes or individual experiences. The White House has released its third National Climate Assessment, or they released it in May of 2014. This report documents the impact of climate change in the United States. The introduction to the report begins with this powerful statement. Climate change, once considered an issue for the distant future, has moved firmly into the present. In this lesson, we're going to analyze climate data as a way to understand this complex issue. First, let's look at a concern that has been raised about climate change, beginning with question 2. The winter in 2013-2014 was the coldest since 2002. The summer of 2014 was also colder than usual. So does this mean that global warming is not happening? Write down a couple of thoughts and answers. Go one way or the other, and then move on to number 3. We're going to look at some information beginning with number 3. This is a great time to hit pause. Make sure that you've got your thoughts down on question 2, and go ahead and look at question 3, at least parts A and B. So a lot's going on question 3. They ask us to open a spreadsheet that they have provided, and that's not a straight line, but they've asked us to open the spreadsheet, which contains the data that we're going to be looking at. The first tab contains the information about the average global temperature between 1880 and 2013. Note that they're in Celsius, not Fahrenheit, which scientists typically use Celsius. And the scale 0 degrees is the freezing point of water and 100 is the boiling point. Each row of the spreadsheet contains a year and the difference between the average temperature of that year and the long-term average world temperature. They want us to make a column graph, discuss any trends. Do the data support the hypothesis that the Earth is experiencing global warming? Go back to your graph, change the chart to scatter, use the spreadsheet menus to fit or find the trend line, and make sure you include, Make sure you include on this one the R-squared value. And then what does the trend line equation tell you about the average change in the Earth's temperature over time? So a whole lot of things are about to happen for A, B, C, and D. Here we go. And do make sure that you're doing this first, making yourself notes and questions and thoughts, and then coming back and watching the video. So I've gone to get the spreadsheet from my math lab, and I've already highlighted columns A and C. I'm going to go up here to Insert, Charts. It's probably going to give me one of the choices. If I want to go ahead and go to All Charts, and then it asks for column, then I can grab this one. It looks very nice. And then they ask us to make the column graph. We did, discuss any trends that you see, and do these data support the hypothesis that the Earth is experiencing warming. And then until right around in here, the average temperature of the Earth was below the long-term average. Between 1937 and 1977, the average temperature moved up and down, and sometimes it was below, sometimes it was above. And since 1978, however, right around here, it has been above the long-term average. The trend for the past 40 years has been that the Earth's temperature is increasing and is above the long-term average. During this time, the temperature has risen 0.6 degrees Celsius above the long-term average. Part C says go back to the graph and change our chart to scatter. So let's see if I can get out of this one. Tell it to insert, and let's ask it on all charts to do scatter. Okay. And when we do scatter, it says, where is this? Use your spreadsheet to find menus to find a trend line and make sure we include the R squared. So let's see right here. Let's include trend line, see what else is available. More options. And let's see down here. There we go. Display the equation and display the R squared. So there we have them, the trend line and the R squared. And it says, we did that. So then part D, what does the trend line equation tell you about the average change in the Earth's temperature over time? Be specific. So looking right here, we have our slope of 0.0075. And with 0.0075, remember we're talking about time, and then we're talking about, yeah, we're still looking at this one. We're talking about time and the increase in degrees. And so a way we can say that is our trend line indicates that on average, the temperature of the Earth is increasing by 0.0075 degrees Celsius each year. That's all that they ask us for, but then let's go ahead and notice we have an R squared, which is 0.81. So about 80% of this variability is accounted for. And then the R, to find it, we could do the square root. And when we do the square root, we get 0.89, which is 90%. And a positive 0.9 in our correlation is very high. And this is very good. These are both very good indicators for what we have on our trend line. We're going to do a little bit more. We're going to click on some more stuff, like we're going to click on our temperature for our carbon dioxide. And we're going to move on to question 4 because it says, click on the tab, temperature of carbon dioxide on your spreadsheet. Make sure you pause, go work on question 4, and then come back and we'll work on it together. So now looking at question 4, it asks us to click on the tab, temperature carbon dioxide. This worksheet shows the data about the levels. It shows data about the levels of carbon dioxide in the Earth's atmosphere and temperature data from the previous worksheet. The carbon dioxide abundance, as it is called, is measured in parts per million, and the measurements were made at the National Oceanic and Atmospheric Administration's Observatory in Mauna Loa, Hawaii. So they're asking us on part A to use the spreadsheet to make a scatter plot of the temperatures and the carbon dioxide data, including a trend line. But first we need to decide who's going to be on the X and who's going to be on the Y. So looking here at the global temperature, is the temperature causing the carbon dioxide, or is the carbon dioxide influencing the temperature? And I believe what we're trying to say here, I'm going to copy this and paste it over here, and let's see if it'll go. Ah, it went. And so I believe what they're asking us is that the carbon dioxide is going to be our X, so it needs to be listed first, and then our temperature. And let's see how this works out, that we have our X first, our Y second, carbon dioxide is influencing temperature. And let's go they're asking us to do a scatter plot. Wow, that is all bunched up there. So looking at scatter, looking here, And I'd like to make that look a bit better, or just leave it alone, because what we're looking at is trend line. I was going to try to shorten it, but we'll just go ahead and go with the options. Where are we? Options, trend line. More options. Here we are. Display the equation and display the R squared. So moving on to part B, it says, what trend do you see? How strong is the correlation between the variables? Make sure you've jotted down a couple of thoughts, even on part C, and then come back and let's discuss them. The trend line is that as carbon dioxide abundance increases, so does the global temperature. The trend line indicates that on average, for every 1 part per million increase in carbon dioxide, and we're looking right in here at the slope, for every 1 part per million increase in carbon dioxide, the global temperature increases from the average by 0.009 degrees Celsius. The R-squared value of 0.857, which means that the R value, by taking the square root, is 0.926, indicates a very strong correlation. So something to note about the R-squared, the coefficient of determination. It is a percentage, and right now it's at about 86%. And so anything, or I should say, the higher the percentage, the better the model is fitting the data. And so we're up at right at 86%, and that is wonderful. And then when we take the square root of this one and we get 0.926, anything that's close to +1 or -1 is also very good. And that is telling us not only the direction of the linear relationship, but it's also telling us the strength of that relationship. So kind of a good idea to remember is that if something is over like 80 cents, either in the positive direction or negative, it's very strong. But if it's less than like 50 cents, positive or negative direction, it's very weak, or it's weak. I wouldn't say very weak, it's weak. Just a quick reminder on those, and then moving on to part C. Discuss why the correlation between the two main variables is so strong. As you know, correlation is not the same as causation. So what could be causing the climate changes? Do you think it's humans who are largely responsible? And then think back to the information you learned in the preview about the greenhouse effect. So as we finish this lesson, you jot down some thoughts, and some things you might consider or include would be that humans are responsible for increased carbon dioxide, and it's clearly linked with temperature increases. The greenhouse effect is a reasonable explanation for the link between carbon dioxide increases and temperature increases. Scientists can also create models that separate human factors and can then see what happens to the temperature. Write down your thoughts, write down your opinions. Maybe this will encourage you to go do some additional research. But this lesson is over. Look at your syllabus, see if you have more parts to do for this week. If you do, keep going. If you don't, stop, and I'll see you on another lesson. But we don't have very many more lessons, so keep going and finish strong.